All right, so if, first of all, good Monday morning to you. If you have the homework done, that's what I need right there. I need to know what the heck is a sine of 2a. If I double my angle, what would be the ratio according to sine? That's my little concept question for you guys here. Boom. And 5-2 real quick here, as fast as I can. Let's do the homework.
Wait, so are we finishing 5-2 today? Or
If I had just 2 things that we did not finish up, but I think as you did the homework, I might just answer with the homework question,
okay.
or I can finish it up. So you guys tell me, what's the feel? You guys need to finish up 5-2. I have 2 more sort of concepts to show you. Or you guys think how's the homework? You finish up the homework.
I think more information on it would be.
Yeah, okay. Perfect. Let's do the homework and then I'll see what needs to be filled in. How about that? All right, Jim, let's go 13. 13 it is. I think it's this one right here. Cosine of 180 degrees minus theta is the same thing as negative sine theta. All right, I'm thinking we're proving this is an identity. Does that show that the following is true? Okay, basically it's an identity. In my mind, I go to a difference formula for sine. That's where I go to. So it's going to be, I think it's cosine minus sine.
Plus sine.
Plus sine. That's right. The cosine plus sine. That's the formula there. We can get it to that. That'd be awesome. So in this case, it would be cosine of 180 degrees times cosine of theta plus sine of 180 degrees times sine of theta. And just see what happens. Oh, you know what I want to do? I'm going to change it to easier to see, I think, here. Cosine of 180 degrees, anyone?
I got one.
Hmm.
I thought it was negative.
Yeah. Let's see. This will be here.
I don't remember that stuff. So it's kind of like, wow.
Wild guess there. Okay. I think almost like you have to have the unit circle embedded in your mind eventually. But -1 is here, cosine theta plus sine of 180 degrees. That's going to be big old fat 0. And that goes away, and we are left with what we wanted to prove, which is that being true. So if you were to graph this guy, right, it'll turn out to be like this, right? That'll be the upside down of cosine. Jamming, okay. Number 17, a little bit more of a toughie. You guys tell me if I'm going too fast. Are we doing okay? Whoa. That was my last slide, not my first one. Number 17, tangent x plus pi over 4. Is that the same thing as 1 plus tangent x, 1 minus tangent of x? Those look so different from one another. Tangent formula would be last time.
Tan A plus tan B over 1 minus tan A times tan B.
Okay, I'll go with it. Tangent of A plus tangent of B, 1 minus, I think it's the opposite sign, right? Tan B, tan A, tan B. Cool. That's what we're thinking in my head. So the answer then would be tangent of x plus tangent of pi over 4, 1 minus tangent of x, tangent of pi over 4, and anybody tangent of pi over 4. Not all at once, but it'll just be 1. It's 45 degrees. Remember, sine and cosine are the same right over here. They're both √2/2 or 1/√2, whatever you like, but the tangent would just be 1. So that's 1. That's tangent of x times 1. And then we make it look exactly like the other side at that point here. So 1 plus tangent x, 1 minus tangent of x, and we are done. And Q, E, D, boom, boom, boom. 29 is the next one. I know, super fun. Who does not want to do a whole bunch of trig homework on a Monday morning? Okay, you help me out here. That I do not know how to graph. But does it fit any of the addition or difference formulas in reverse? See,
It's
You can factor out 3 and then
okay, factor of 3, that's fine too here. So 3 goes on the outside, and I have cosine of 7x, cosine of 5x plus sine of 7x, sine of 5x. Okay, Karina?
It's just the sum formula. Or the, maybe it's, no, it's the difference formula.
It's the difference formula, yep. So it's cosine of, let me write it a little bit higher here. It's cosine of a minus b. And for cosine, just the way it works out is it's always the opposite sign of whatever this guy is.
But then for sine, it's always the same sign.
Correct. So in this case, it's going to be 3 and it'll be cosine of 7x minus 5x. And now we are graphing, which I think we know how to do now. Graphing of this guy, 3 cosine 2x. Back to graphing. Oh boy, here we go. Thought we got rid of that. Thought that was chapter 4. Amplitude is 3. Period is 2 pi divided by this little guy right here called 2. So my period is pi. And yeah, phase shift. Phase shift is 0. There's no phase shift here. We're not adding anything to the 2x. So if I go out to pi over here, that would be pi over 2, pi over 4, 3 pi over 4. Awesome. And amplitude is 3. So 1, 2, 3, 1, 2, 3. So cosine curve, amplitude 3. And it goes out to pi by the time we do 1 complete cycle. So boom, how about that? Down to -3, up to 0, up to 3, done. Love it.
I think it also wanted you to graph to 2 pi.
Oh, gotcha. Sorry. Graph from 0 to 2 pi. So we just keep on going then. That will be 5 pi over 4. 6 pi over 4, which is the same thing as 3 pi over 2. 7 pi over 4. And then 8 pi over 4, which is 2 pi. So then, thank you, my man. Keeping me honest. Okay, that's fine. We'll do it that way then. Did you guys hear about haha. Okay, gotta go on my science nerd thing, okay? Something called, I think it's called star shot. Did you guys ever hear something like that? No. Huh? Okay, break from the homework. We good? Just real quick here. So it's these. Basically, in a sense, it's just like little chips, microchips, size of a stamp-ish. And what they have is they have these it's connected to a parachute, but a parachute, is that okay? Can I go like this? It's a parachute, but here's a little chip. And what the company says they can do is if they shoot a laser beam at this parachute-ish material, it's going to start reflecting the beam. And because of that, it's going to go approximately 20% the speed of light. That's like fast. The chip.
Oh, so it'll start to move.
They'll start to move, yeah. So they're thinking about putting like 2,000 of them in space and then shooting the laser and letting it go to Alpha Centauri and then take pictures and then, so let's do the math, guys. Let's do the math. So 4.3 years, 4.3. Say again, Georgia?
I said, I thought you said we're taking a break from the math.
Sorry. So this is so fun. Okay, so
4.3 years is like no time.
Yeah.
4.3 is light years away. So if you could travel the speed of light, it'll take you 4.3 years to travel to Alpha Centauri. We're traveling 50% of the speed of light. So how many years to get there?
Wait, 20,
20% or 50%?
Sorry, going 20% of the speed of light. How long will it take to get there? Okay, 20 point.
20.35, which would be 23.5.
We are totally.
How long it would take us
Because you
to
just
go 20?
multiply by
Oh,
5.
20.
Yeah. So if it's the speed of light, it's 1/5 the speed of light. So we can go this guy. So 15. That good? 21.5. We good? I think so. Okay, the fun stuff. You guys ready? So when this little chip gets to Alpha Centauri and the solar system there, and it actually takes pictures of, it's supposed to take pictures of planets. It's supposed to do a lot of this because it's a whole new solar system. And then it's supposed to send the images back to Earth. We're good? Images travel the speed of light. So how many years will those images still?
4.3.
It's going to take, so we're, to get some pictures, we're going to wait about 25 years.
So by the time we're all dead, we will have seen pictures of.
You're gonna be dead.
Yay.
Yeah.
That's a plan.
That much time. I don't know, like 1,000 years.
Yes, 1,000 years.
It's only 25.
25.
I was like, what are your plans for your life?
That's funny. But I thought that was kind of cool. And the weird thing is,
I'm planning on living past like, what are we gonna be, like
40-ish or
40
so?
something? I'm planning on living past that, but I mean, you go and die.
Anyways, I thought it was kind of cool.
You can watch on his way out.
You know what?
You just flat out.
How do you much more?
I will volunteer to be the microphone.
Oh, yeah.
I hope you don't lose that spectator.
She should be dead. You don't understand what's happening. I'm not gonna be like, no, you don't understand.
Hopefully Alpha Centauri is on the map.
Okay, so back to math here.
It's the Alpha Centauri deal.
43 is this one. Proving this, prove each identity. What do you guys say? Any suggestions?
Use the sum formula for the first part and the difference formula for the second.
Go that sum formula for sine. Look it up if you need to, but I think it's sine of a plus b is sine a cosine b plus cosine a sine b, I believe. Difference formula would be sine of a minus b is just a sign change. That's it. And these should be kind of in a thinking box here because that's what I'm thinking. Sine of a cosine b minus cosine Let's switch around here. Cosine of A sine B. Boom. And so the next line should read sine of 90 degrees cosine of x plus cosine of 90 degrees sine x. That's the first one here. And then the second part here is sine of 90 degrees cosine x minus cosine of 90 degrees sine x. Boom. Sine of 90 degrees. That's 1, correct?
Yes.
Cosine of 90 degrees would be 0. 1 again. 0 again.
Isn't it the other way around? Sine is 1 and cosine is 0? Or did I make that up?
No, sorry.
Good, you guys talked to me.
90. That's what he did.
Yeah.
Sine of 90.
Yeah, I may have said it right.
Oh, I get it. I'm sorry.
No, no problem. That's 0. That's another cosine. That's 0. Perfecto. I think we got what we needed. This is 2 cosine of x. Let me write it correctly here. Is equal to 2 cosine of x, and we are cool like that. Okay. All right, something that I have not done as much as is radian measurement, but it's the same thing here. So 47, last one here, is sine of pi over 6 plus x plus sine of pi over 6 minus x. Is that equal to just a regular old cosine? Cool. Let me start you off on that, and then we'll go from there. Again, it's the same, exactly the same thing as 43 here, except radian measurement here. So look back to 43 for the formula. It's sine of your first angle, cosine of your second angle, plus cosine of the first angle, sine of the second angle, and that's the sum formula. Difference formula, just going to have a sign change. Everything else remains the same. Boom. Okay, I'll finish it off here. Anybody help me out? What's sine of pi over 6?
Is it 1/2? Or is it the square?
Okay. 1/2 is the winner. Cosine of pi over 6. So in my mind, whenever you deal with pi over 6 or pi over 3, it's always a 30 or 60, 90 triangle. And imagine always which one's the further one away from the origin, cosine or sine. And I usually do this right here, right? Because you can tell, in your mind, I think you can tell how far you are climbing up. So pi over 6 is only a 30-degree up value. So that means this guy has to be the 1/2. That means the other one has to be the √3/2. Or you can do the triangle, because this one will give you the longer side, this will give you the shorter side. So √3/2 sine of x. There's another 1/2 right here. And this one's going to give you a negative √3/2 sine of x, and voila, these guys are gone. And I got 1/2 plus another half gives you a whole piece, and we are finished. Okay, are we jamming? Is that good? Sure. See if it is part of this here. Okay, so talk to me here. As far as homework is concerned, kind of in the 30s, 34, 35, 36, 37, 38. Did we have any homework questions from there, or did you guys do any of that? There was no homework questions there, right?
There wasn't any.
No, okay. I think I set this up just to get us ready for the next section here. What time we have? Boom. Let's do one because it'll help us get ready for the next section here. So 5.2, just the two final problems setting up, and then we'll jump to 5.3. We good? This is finishing up lecture for 5.2. Continued. And which example problem, or are we exercise problem on? Number 5? Cool. Okay. And so later on, we'll have these ones. This is our first look at it here. So let cosine of A equal to negative 5/13 with A in quadrant 2. Sine of B is equal to 3/5 with angle B in quadrant 1. All right, and the other trig functions follow as well. So cosine and tangent are going to follow the same way here. But here's what I have. I have a ratio that I know. I have no clue what this angle is anymore. I just know that the cosine ratio for A is negative 5/13. I know that the ratio for sine of angle B is 3/5. What I want to know is I want to add the two angles together, and I want to get the sine value of what that would be. So again, have no clue what the angle measurement is. So let's think here for a little bit here. I guess we'll go back over here. So sine of A plus B, what information do I need to know in order to complete this? And so it would be the sum formula for sine. So sine of A cosine B plus cosine of A sine of B. Everybody good there? That makes sense so far? Now we can plug in the values we know. Oh, you know what? Might just get stuck here. Let's see. Sine, we don't know what sine of A is. We know what cosine of A is. Hey, you know what? Off to the side. If we know what cosine is, can we figure out what sine would be? So for angle A, we have to draw it in quadrant 2. So it's a little triangle right here somewhere. There's my angle A right there. And so what do I know? All right, you have a choice here. You can either put it on a unit circle and make cosine or the x value to be negative 5/13. I would not suggest that. Or you could pretend it's not on the unit circle. And so the cosine value is just negative 5 and the r value is 13. I like that better since I don't have to deal with fractions here. So all yours. What would be the y value at that point? I'm hearing like Pythagorean theorem, kind of stuff like that. I don't know. I'm thinking, let's see, it would be x plus y is equal to r or squared, right? X squared plus y squared equals r squared at that point. So negative 5 squared plus whatever y squared would be becomes 13 squared. Almost done. 169 Subtract 25 from 169 gets you 144. Oof. And answer is, it's 12. Technically, we should put plus or minus 12 in here. And then from that, we go back up here, then we just we take the positive 12. Cool. Okay, now the question is, what is sine of A? I like 12 over 13 is good by me. Do we know cosine of B? Oh boy, I think we might just have to do the same thing. Oh, no fun.
Isn't it just 4?
It's 4, uh-huh. This guy's angle B, it's in quadrant 1. The sine ratio is 3 to 5, so that means the y value is 3, r value is 5. In this case, we're missing the x value this time. Oh, 9, 25, 16, plus or minus 4, and what we do is we take the positive 4 out of it, not the minus 4. Okay, talk to me here. I'm going a little fast here. Does that make sense? Okay, the cool thing is here is that we're trying to figure out a trig ratio from two angles we have no clue about. We don't know what the angles are. We just know the other trig ratios for that angle. In this case, cosine of B is going to be the x value over the r value here, so 4/5. The rest is, oh man, the rest is easy. This one, yes. This one was given. So it's this little piece of finding the missing values. I'm thinking what, 48 over 65? Here would be a plus -15 over 65. And anybody help me out here? I'll do the hard part. I'll put 65. 33. Boom, there it is. That's awesome. So what in the world does this mean? Is that I have a ratio here of angle B, let's say, right? And then angle A is over here. And so if I were to add this up, that's angle A. Oh, sorry, that's angle B. That's angle A. I've added both of these up. And should most likely was going to land over here somewhere. Are we good? Because I need to add angle A is coming all the way over here, right? Let me draw it correctly here. So angle B is like this, approximately, because that's what we got right over here. Angle A is this big, large angle right here. So then I'm going to take this as angle A. It's going to probably do something like that. And it probably gets into there. So we're probably in quadrant 3 somewhere as we added those two angles together. Okay, does that make sense? Maybe, sometimes. Okay. Okay, I think we're good because we have enough proving identities here. There's some more practice on identities here. Okay, let's jam. So 5.3, I think we can put this together.
Do you think over 5.2 we could do one more example of like doing tangent? Because
Tangent?
I feel like we only had one of those on the homework and we didn't do any in class.
Yeah, let's see. Let's see. What would involve tangent? Let me check here. Okay, let's do something similar to this guy here. So how about this will be example 6 then. All right. To practice this, because we'll need it later on anyways here. So sine of A is equal to 3/5 with A in, is that the same? No, that's different. Okay, just want to make sure. In quadrant 1. And I have cosine of B equal to, that's no fun because they're all the same here. Let me see if I can get another value real quick here. Sorry, searching for some values here. I'll still go with it then. Let me switch them around. Go with it here. This one. So sine of A is 3/5. We're in quadrant 1, so it's this little angle right here. Not bad. It's let's see, more than halfway. So here's my angle A. Angle B is all the way in quadrant 3. It's all the way down here. It's this guy here. And what I'm trying to do is trying to add those up. So if I were in the middle of an angle, let's say if I was in the middle of quadrant 1 and I was in the middle of quadrant 3, if I were to add those up, what's 70-ish, right? So if I were to add these two angles up together here, I would be somewhere around in this range. I could still be in quadrant 3 or I could be in quadrant 4. I don't know because I don't know the angle. Okay. We might know based upon our value for tangent. We'll see. Anyways, let's go for it here. So formula is tangent of A plus tangent of B, 1 minus tangent of A times tangent of B. There's my little formula. And I don't know any of those. I just have a ratio for sine. That's all I got. I'm adding up two angles I don't know in order to get the tangent ratio. So let's try this here. Sine of A, that means the y value is 3, the r value is 5, and everybody was okay with the x value already? Did it last time here, that's 4. Ooh, so I think I got a piece of it here. Hold on, let's see. Anybody give me tangent of A then? It is going to be, it's going to be 3/4. Tangent of A is y over x ratio, and how about 3/4 for the ratio? Done, done. Going back over here, this guy is in quadrant 3. The x value has to be the negative because 13 is always going to be positive. It's the distance from the origin to the point. Anybody know what y is?
Wait, where?
Oh,
Oh.
12 is good. Give me sine tangent of B. I'll go with that, right? It's the y over the x. Boom. So negative 12 over 5 is here. 1 minus. Now it's the multiplication of the two together. And a little bit of work here. 20 is the common denominator for the top. So I'm gonna go with 20 here, 20 there. So tell me if you guys agree here. It's gonna be multiplication by 5 here, so 15. This will be multiplication by 4 and 4 makes -48. And then this one's gonna be the multiplication of those guys together. So how about, there's a minus in front, there's a negative on the inside, so it'll be plus 36 over 20. All right, and this little one could be changed into a 20 over 20. And almost there. Let's see, on top, I got myself 15 minus 48. Anybody? 33 again? Negative 33. Okay, on the bottom, I have 20 as my common denominator, 56. You think? Okay. And then change division into multiplication by taking the reciprocal. Our bottom values, the 20 and 20 reduce themselves out or cancel, and I'm left with -33 over 56. Okay, does that help? At least a good practice there-ish. I didn't find any. Yeah, we did the formula for it. We did the value there too. Okay. Okay, now good. All right, let's begin. We have 5 minutes left here. That's no problem, because we just need the concept out of this anyways here. So 5.3, it is called the double angle formula. And we're just building these things because we are cool like that. So, boom, here's what I need. I need to know what in the world is sine of 2a. So this is, if I know my angle, I want to double my angle and then get the sine value for it. I'm going to sing Jeopardy, and you guys tell me how should we arrive at sine of 2a.
Something crazy, guys.
Yeah, go ahead.
Sine 2a is actually just sine a plus a.
No way.
Wow.
That's too crazy.
Whoa. Wow. Wow, Adrian, how did you come up with that? I just didn't want to hear the Jeopardy theme. Understandable.
Absolutely. It's just what we learned in 5.2. What we learned in 5.2 is just the two angles being exactly the same. Perfecto. So this is sine of A, cosine A plus cosine A sine A. And we get ourselves 2, right? 2 of these guys.
Wow.
That's awesome. Let's see what we have. We have 5 minutes. Okay. So there it is. Write it somewhere if you need to here, or just refer back to the back of the textbook. If we're going to double our angle and we know the original angle, we're going to take the sine value of it, the cosine value of it, and multiply by 2. It'll be back to the book. Front cover, second page. It's going to be called the double angle formulas. Okay, got that one. We'll continue with it on the next one here. And then I guess we should do cosine. Let's see what happens with cosine. Still the same process, right? Cosine of A plus A now, because there's 2 A's in there. And then we have cosine of A times A. It's cosine of A, isn't it? Minus sine of A, sine of A. that's the case, okay, I go with Grant here, cosine squared A minus sine squared A. Just a quick little venture here. So now my little question is this.
Wait, does not equal
Oh, that's right. Hold on. Don't we have Pythagorean theorems? So
Whoa.
let's box this up as one formula. Let's see if we get a second formula. So Pythagorean theorem says, and then maybe a third formula.
They wouldn't do that. They wouldn't have to.
Oh, wait, yeah, they would enforce it.
That's ridiculous.
So sine squared A is not the same thing as 1 minus cosine squared A. So let's use that one. So jump from here. We're going to substitute. And just see what happens here. If we're going to substitute this guy. And if that's the case, what's that? -1. There we go. -1 plus cosine squared A. So eventually I get, how should we write it? Maybe like 2 cosine squared A minus 1. Everybody agreed there? Boom. Oh, but wait. We can have sine squared A is equal to 1 minus cosine. How about the other way around? Can we have a cosine squared A is equal to 1 minus sine? Is that our other derivation of our Pythagorean theorem? I should have said it this way here. The arrow comes through this way. And then the arrow is going to come through this way for the other one. If we substitute cosine A in here, so that means this would have been 1 minus sine squared A. Okay, are we good there? Let's see if that makes sense. Is that making sense in our mind? If that's the case, we drop the parentheses. And we got ourselves 1 minus 2 sine squared A. And but wait. No, just kidding. So that's weird. So sine has only one formula. Cosine just happened to be the fact that we have now 3 different formulas and all had to do with the Pythagorean theorem. So the question is, when to use which one? I guess we'll see next time. All right, and your job in your spare time, since we haven't really started 5.3, your job in your spare time is your sort of homework assignment-ish, is to do tangent of 2a. Okay?
Wait, can you go back?
Go for it, Greg. I'm ready back.
Might not even be in the textbook when you're done.
Oh, no.
All right, never mind.